Bridge inspection is a costly, time-consuming, and ordinarily quite dangerous process. However, advancements in drone technology allows for an alternative that can effectively mitigate all of these issues and more. This is why Team BRI6 is confident in its UAV-centered solution to inspecting the underside of the Ted Smout Memorial Bridge. In the first stage of the mission, when the team is arriving at Pelican Park, situated roughly 20 kilometers northeast of Brisbane, the team will set up the ground control station and prepare all the equipment for the mission that is to be loaded onto a hired boat. Once the UAV has been tested and cleared for takeoff, the UAV will accompany the boat to the bridge, where a landing and battery swap will be conducted remotely, after which the survey process will commence.
The section of the bridge to be surveyed consists of 15 spans, which will be scanned in pairs. Between each pair, the UAV will return to the GCS for a battery swap and a data download. Excluding the very first trip, whilst the UAV is surveying the bridge and photographing the underside to a minimum resolution of a pixel per millimeter, a technician will review the data from the previous spans to guarantee zero file corruption or motion blur. Once all the spans have been surveyed, the team will pack up and head home for data processing, as the data collected is sufficient to generate a full composite image of the underside of the bridge, ready for specialist review. The UAV that will be used for the mission has been specifically designed for bridge inspection. The UAV has a multi-rotor quadcopter frame and has similar components and systems to an FPV drone. It features a 36-minute battery life when running at 65% throttle, or 49 minutes whilst hovering in a stationary position.
Testing will consist of detailed processes which have been streamlined into suites of tests. These tests may be outsourced to individual parties in order to accelerate the process and remove issues with other testing prerequisites. Once the testing is complete and all test procedure forms are filled out, which includes calibration and diagnostic methodologies and manuals, the UAV is ready to be sent to CASA for final approval. There are many risks involved with this mission. Some of these include system failure, terrain navigation, and environmental factors such as wind, tides, or wildlife.
Consequently, the team has placed preventative and mitigative barriers to effectively minimize the probability of an incident occurring, as well as the consequences should the improbable happen. This includes having a paper trail and detailed traceability that also serves to ensure the UAV completes all mission requirements with the highest level of safety. Our UAV is pushing the boundaries in the state-of-the-art, matching specifications in commercial products such as the DJI Matrice 200 series, which retails for roughly $18,000. We've integrated full support for a robot operating system with extended Kalman filtering for a precise position fix, even when there are bursts of GNSS denial that would otherwise compromise the odometry. Our hardware offers full pilot immersion through the latest DJI products for a high-resolution virtual reality experience. When you're flying our drone, you're in the pilot seat.